You're all like, you say a lot of shit, Jeff. What do you want from us? Okay. So, can you guys tell me what that is? 1 over 10. I love it. How do you know that so quickly? You didn't have to do any work. How do you know that? Did you just memorize it? Yeah? Okay. So let's do better, right? Can somebody tell me what this is?
1 over 200.
No. What would this be?
1 over 100.
1 over 100. So if I double it,
2 over.
2 over 100. Right? Is that cool?
Yeah.
Since it's in our number system, it sits in our places, it has to be based on a power of 10. So all decimals are fractions whose bottoms are powers of 10. That's why they fit into our number system. Why? Could I write this like this? Yeah, of course, right? But why do you think we write like this normally? Why do you think? You guys see this more often from teachers than this?
Mm-hmm.
Maybe? Why do you think we do this?
To indicate.
Yeah, because what's probably the easy thing to lose would be the little decimal point. But if it's 0.1, now it's harder to lose it. Because you wouldn't write, there's only one person coming. Who the shit writes 1 like 0.1? So if I see 0.1 and I don't see that, I'm like, oh, they meant 0.1. Yes? Okay, so just because that decimal place is really easy to lose. How about this? Is this decimal? Is the bottom based on 10? No? Can you make the bottom based on 10?
Yeah.
Yes. What could you do?
Multiply by 2.
Yeah. So if I multiply by 2,
0.4.
I'll get 4/10. Yes, which is 0.4 kick ass. Is that cool? Allah. Yeah. Exactly. Totally. So here, just pushing this a little bit. Take a minute, don't say anything. Write that as a fraction. Let's see what you guys think. All right, we set up a pattern, haven't we? That's 10. That's 1/100th, right? That's tenths, hundredths. So let's see if you can continue that pattern and write this sucker down. Those brownies are right there. Tempting me.
Count pretty good.
Yeah, they
Don't mean to toot my own horn, but
Oh, yeah, 2 to white, man.
I'm like,
It's all right.
Very good.
You're in a safe space. You can 2 here. All right. Who thinks they have the answer?
it's a 23,149 over 100,000.
100,000?
Yeah.
So we got one suggestion for 100,000. Has anybody else got that same thing or something different? Here's a really cool shortcut. No, here's the long cut. Tenths, hundredths, thousandths, 10,000ths, 100,000ths. Okay, so now I know. Here's a shortcut. How many decimal places are there here? How many decimal places? 1. How many zeros?
1.
How many decimal places? How many zeros? Interesting. How many decimals? 1, 2, 3, 4, 5. How many zeros? 1, 2, 3, 4, 5. Kick ass. Because every step I take is another 10, and when I multiply by another 10, in this case, divide by another 10, but I pick up another 0, right? So that's beautiful. I'm sure some of you guys knew that shortcut. Yes? Maybe? No? Yes? Okay. Let's see. Oh, what about this? I want to make that into a decimal. The most direct way would be to do what?
Multiply by 10.
Say again?
Multiply by 10.
No, because that would make the bottom 80, which is not some power of 10, right? The bottom needs to be 10, 100, 1,000, of course, so it fits into our number system. Is it easy to make 8 become 10 or 100 or something? Is it easy? Do you know it right off the bat? Do you? What is it? How do you do it? You leave me alone. Okay. So you could, I'm surprised nobody's said this. Just divided anything, right? 8 to 7, long divide. Yes? Do you want to do that? So let me show you a different way to do this. So every single fraction in existence is can be represented as a decimal. Some of them, does anyone know what's special about the fraction 1/3, for example? There's an infinite number of these, but 1/3. Does anyone know what the decimal looks like for 1/3? It's point three, yeah, forever. Yes? So every fraction can be represented decimal, but some of them will be forever repeating decimals, or, right? Are you guys with me? There might be some repeating, some what's called non-terminating. They don't terminate, right?
They cannot self-terminate.
So this terminates. Okay, that's great. This one, so this fraction, watch this. Here's a cool thing you can do. Factor 8. All the way down.
4 and 2.
And then all the way down.
2 cubed.
2 cubed. Now watch, this is a really cool, not trick. But again, remind me, what do I want to have end up on the bottom to make it go right into a decimal? What do I need on the bottom? I need a bunch of tens, right? So if on the bottom there's a 10, great. 100, that's 2 tens. 1,000, that's 3 tens. Beautiful. I need a certain number of tens. If I have some 2s, what do I need to make tens?
5.
And how many 5s do I need?
3.
Because I got 3 2s, yes? So if I put a 5 with each 2, I'll end up with some tens. Does that make sense?
Yeah.
Okay, so if I give this 3 5s, how many tens do I end up making?
1,000.
Well, 3, right? 3 tens, 1,000. Are you guys with me? Every 2 pairs with the 5, so 1 10, 2 tens, 3 tens. 10 cubed, which is 1,000. And on the top I get whatever that is. So 100, 200, 875, maybe? Somebody help me out. Have some passion. I think I'm wrong, but that's all right, Jeff. Things happen. I could be wrong. 875?
Yeah, 875.
Yeah, look at me go. Yay, Jeff. Teaches math and he's able to do math. Holy shit.
We never doubted.
And now, here's the interesting question. We haven't done this yet, so this is a little more complicated, but let's see if you guys, how do I make that into a decimal? What do I have to be careful about? So here's what's different about decimals. Why was this 100,000?
Because of the places.
What place is this in? Tenths, right? One's place over there.
Yeah.
Tenths, hundreds, thousands, I don't know. So the last digit in a decimal tells me what that is, right?
Yeah.
So this is over 1,000, so the 5 has to be in the thousandth place, right?
Yeah.
You guys with me?
Yeah.
So let's see, tenths, hundredths, thousands. There you go. Okay. And again, some of you guys might have no trouble with that. Some people have trouble with that sometimes. It's because it's really weird. It's backwards. Like here, how do I know what that 4 means? If I write this correctly. How do I know what that 4 means? What does a 4 mean?
Million.
Million. Why? Because it's in the millions place, right? So on the other side of the decimal, so there, this way. On the other side of the decimal, it goes this way. So I say whatever this is, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 million. Okay, so right, so it's kind of nifty how it goes out that way. Okay, maybe does that make sense? What I just said? It's a little weird what I just said, but and that's why sometimes it could be hard to put fractions into decimals because you have to think that has to end up in this spot because it's the last digit that tells me what spot I'm in. Now, real quick, I want to show you something kind of nifty. Let's see what you guys think. All right, let's look at that 0.875. Would you agree with me? This is getting ahead of us a little bit. That this is this.
Yes.
right? What is 0.8? What is 0.8 as a fraction? 8 over 10. And what is 0.07 as a fraction?
7 over 100.
And what is this as a fraction? 0.005. I like it, right? Now what's wrong with me trying to do this problem? Can I just add these together? What do I need first? So what will that be? Yeah, 1,000. He needs a 10, and he needs a couple of 10s, right? So you actually end up with 800 plus 70 plus 5, and that's how you get to 875. And again, that's why the last dude controls this, because if you actually think about it this way, they all have to become this to be like terms. I don't know if that makes sense. I'm not even sure if anybody has a problem with fractions in this way, but sometimes I run into people who do. Okay, but this is still good to know. This is still kind of nifty to see. And it also will explain later when we get to adding decimals why we have to line up the decimal places before we can add them. So I'll come back later. Okay. All right, now, if I give you a hammer, no, if I give you a number line, let's go 0, 1, 2, 3. And if I ask you to find 0.5 on that number line, is that a difficult question? Can you find 0.5 on that number line? Where is 0.5? Exactly.
0 and 1.
Exactly halfway here. Okay. I like it. What if I ask you to find 1.25? And let's say I want you to be a little more precise with where you put this dot, right? What can you do here to help you find this? Dash lines, and how many cuts will I make? We'll make 4 spots, so make 3 cuts, right? So halfway, let me do this one step. So go halfway, pop, and then go halfway between each of those, pop. And then 1.25, of course, is also known as 1 and 1/4. There you go. Now, of course, if you're teaching young ones this stuff, remember, what's the thing I keep saying? Every time you start to introduce something new, what do you try to do? Build it back on something that they're maybe not comfortable with, but at least they've been exposed to before, right? Make connections between what they know and what they're learning. All right, anything else freaky there, Jeff?
So for example, the decimalization of 1/4, how would we bridge that for them? It's like, how would it be like?
Well, okay, again, so if I just wanted to look at 1/4, and based on what I've talked to you, now obviously when we talk about something, that would become maybe 1, 2, 3 days worth of lecture for you, right? Or working with students.
Yeah.
So what did I say earlier about converting a fraction into a decimal? What's the easiest way to do it? That doesn't always necessarily work, but what's the easiest way to make this into a fraction if I make the bottom 10 or 100 or 1,000, right?
Yeah.
So I can't make 4 to 10, but I could sure make it into 100. What would I multiply by?
45.
And there you go, there's your 0.25, right?
Okay.
But what do they also understand? What do you think they also understand? Tell me, how do you say this fraction? How do you say this fraction?
1/4.
1/4.
A different way.
1 divided by 4.
No. No, it's not what I'm looking for.
1/4.
I love you guys. You can do this. If it was 6/15, you'd say it's what past 6?
1/4.
All right, so another way to say 1/4 is a quarter, yes?
Oh.
Right? Okay, I love it. So what are the kids maybe understanding, possibly, in their life that relates to 4 of it making a whole thing?
Money.
Money. So you could say, this, we call this a quarter. A quarter is 25 cents, right? And what does it take 4 of? Why does it make sense that this is 1/4? Because it takes 4 quarters to make a whole dollar. So that's why 1/4, 1/4 of a dollar. I love it.
So we could probably use like decimals and fractions. That's like a
Yes.
symbiotic thing, and then like
Yeah, that's a beautiful little quick example of
a segue.
what we call the fraction, what it looks like here, and how it relates to something in real life.
Yeah.
I mean, money can be used to kind of work with a lot of mathematical ideas, like negatives and positives, right? Balancing your checkbook, negatives and positives. And then you got
We'll
this.
still have coins, by then.
Huh?
Who knows if
Oh,
we'll
yeah,
still
yeah,
have coins.
yeah. Well, a quarter of a Dogecoin or a quarter of whatever. A Musk coin, I don't know what we're gonna get next. Who knows? All right.
It's all gonna be like, got coin 0.00008 for lunch tonight.
Yeah. Okay. So let me expand on something we did earlier. How would you make this? Could you make this into a terminating fraction, whatever that is? Terminating decimal. Can you make, what does that mean? What am I trying to say? How do you make something directly into a decimal? The bottom has to become 10 or 100 or 1,000, some multiple of 10, right? And we can see exactly what this is missing. It's got 2 2s and 1 5, so of course it needs 1 more 5, and then it can now be making how many 10s? 2, right? Does everybody get that? Every 2 and every 5 go together, and I got 2 pairs of 2 and 5. So if I give this a 5, that'll make 10, 10, that'll make 100. Cool. So this will be 0.55. Yes. So if the bottom can be made into 10, 100, 1,000, then it is a terminating decimal. It will have a terminating decimal representation. You see how slow I was talking? That's a good note to take. In fact, that is what the book calls a theorem. So the theorem is, if A over B is in simplest form, meaning it's already been reduced and whatever, and yeah, A over B has a terminating decimal representation. I can't speak anymore. Representation. I think I need a brownie.
What is that?
Terminating decimal representation. If and only if. There's a lot of words. If and only if. The bottom, if and only if B contains. This is a lot of words for something very simple. Only 2s and 5s. If the bottom only contains 2s and 5s, I can always find some multiple of 10 for the bottom. Does that make sense? We've already done it a couple times. Yes?
What's the word after the second A over B?
Has. This one?
Looks like he's.
Oh, okay.
HCS.
I think I told you guys, the minute I can't read my own writing is probably when I'm gonna retire, but, cause I had a teacher, and you would ask the teacher, what did you write up there at the top? And he would go, does somebody remember what that was? I'm like, what the hell is happening? So I'm not quite there yet. So what I really want this, so watch this. If I have this fraction here, 7 over 15, will that have a terminating decimal representation? What is the bottom made of?
5 and 3.
And 3. Shit, can't do it. Right? Do you see what that says?
Yeah.
If B contains only 2s and 5s, because that's how you make a bunch of 10s. The minute you throw a 3 in there, 3 times what is 10? 3 times what is 100? 3 times what is 1,000? You ain't gonna get shit. I really want this to make sense. So that's why 1/3 doesn't stop. Because it's got a 3 on the bottom. It doesn't have any 2s. It doesn't have any 5s. It's got a 3. It sucks. But 11/8, the bottom has only got 2s. So I just got to feed it some 5s and it'll be golden. It'll stop. You guys semi with me?
Yeah.
Yes. Oh,
So
sorry.
you said 2/8, you just have to feed it a 2.
Say again, sorry?
You said 2/8, it's 4 and 2, so you'd only have to feed it.
No, so 7/8, like the one we did earlier. This had only 2s in it, right?
Oh,
And again, when I say in it, I mean break it all the way down.
okay.
Yeah, because the 4 has only 2s in it. Does that make sense? Yes?
What's the name of this theorem?
The book didn't give it a name, and to be really honest, it's not really a theorem, but the book likes doing that. Oh, what page am I on? It's theorem 7.1. There you go.
Page.
So, do you see how this is based on 3? The bottom, right, has a 3 in it. So it's kind of related to like 1/3. What, somebody got the calculator out?
Yeah.
Do 7 divided by 15. What does your poor little calculator say? 0.4 or something?
Yes.
0.46667, but it ends in 7, but it's
But you know it's really gonna be
all 6.
466666666, right? And is everybody cool with that? Remember what that meant?
Yep. 1,000.
No, we're not in Roman.
That's in
I
Roman.
love it. I love that though. What does that mean for decimals when I put a little line over a number?
Like infinity.
Repeating.
Repeats forever. So this, if I wrote this, what does that look like?
2727.
Good, 2727. Whatever I put that bar over, that chunk repeats. Is that cool? Maybe? A little bit. All right, let me see. All right, I'm excited now because I'm going to show you something freaky. All right. You don't even have to write this down because well, actually, I can't remember if it's in here. It might be in here later. I'm going to show you something kind of nifty. Don't do this in your calculator. Don't do this. Does anyone know what 1/9 is as a decimal? If you do, don't say it, but just tell me if you do. Does anyone know what it is? Okay, let's do it. We're gonna figure it out by hand. Oh, this sounds exciting, Jeff. Exactly what I wanted to do. We're not gonna long divide. That's for chumps. Right? It's better than that shit. This has an answer. This will be some decimal, but will it be a terminating decimal?
No.
Why not?
There's no 2s or 5s.
The bottom has 3s, right? Even add some 2s and 5s, as long as it has anything that's not a 2 or a 5, it's screwed.
Yeah.
So I know this is going to be a decimal, but it's never going to stop, right? So do we know what that is as a decimal? No, Jeff. That's what we've been talking. What do we do in algebra when there's something we don't know? What do we call it?
X.
Okay. So I'm going to call this X. Let me see. Am I doing this? Oh, okay. Damn it. I always do this backwards. All right. Hold on to this. Just put this in a pocket somewhere. Let me do this the right way around. All right, car. It's okay. Getting heckled by a car. Great. All right. Pretend like this is where I started this. So I kind of gave the answer. That's going to be that. We're gonna prove that this is that. Right? It's sort of like I told a punchline first for a joke. Shit. Do we know what that is as a fraction? Pretend like we don't.
No.
So let me call it. Let me do it this way. Let me call this. Yeah. X. Let me call that X. Okay. I like it. That's okay. Now it makes sense, Jeff. Jeez, get your story straight. This is really cool. All right, so stay with me. This is kind of cool. I don't know what that is as a fraction, so I'm going to call it x. Why does this decimal particularly suck? In fact, why can't I tell what it is a fraction? Don't we normally, if I see a decimal, don't I just count over to the end and then put it over that many zeros? 1, 0, 0, 0. Why can't I do that here? Because it goes freaking ever, right? So I would put infinite zeros, right? I don't have time for that. Ain't nobody got time for that. So what if I multiply both sides by 10? What happens to a decimal when I multiply by 10? Who remembers? The decimal moves by 1. Every place that's there gets 10 bigger, so they all move one place over. Does that make sense? So that decimal's going to move there. So now it's going to be 1.111 forever, yes? Stay with me. This is kind of cool. Now watch this. What's 10x minus x? 9x. And what's 1 point shit minus shit? 1. No see shit anymore. Shit, cancel. Right? You guys see that? 1.1's forever minus 0.1's forever. The 0.1's forever cancel. And now how do I solve for x?
9 times what is x? Or 9 times x is what?
9 times what is 1? I love it. So 9 what's make 1? 9 1/9 make 1.
It's the brownies.
So that means that 1/9 is this decimal. And now let's see why you should have really known this. Can somebody tell me if 1/9 is 0.11 forever, what is 2/9? 0.22 forever, right? So what the shit is 3/9? And what is 3/9 also known as? 1/3. Shit, you guys knew that, didn't you? Right? Yes?
Was there like a problem that we might have done in high school that used this? Because I
Definitely.
think I remember learning.
Definitely. This idea could be taught in so many different places. So that's why I can't remember if it's in the books somewhere, to be honest. This is something I show, and some books I've used have it in there, but most books don't. But this is kind of cool, no?
Mm-hmm.
So what would this work for? Any decimal that repeats forever, this would work for, right? Even 0.272727, this kind of thing would work for it. Okay. So we're done with that little tangent. All right, I like it. So we already did that. So let's do this. Can you put these in order from smallest to biggest? What is it, Jeff? You're all like, I'm done. No, wait, let me write something down. 0.07. 7001 and 0.71. I'm gonna have to have it if it'll come out of there. You want me to eat your head. So one of two things are happening right now. You're doing it, and you kind of understand how to do it, or you're not completely sure. But if you know how to do this, can you understand why it would be difficult for a student first learning this stuff? If I just glance at this, what would somebody who's brand new to this show, what might they think the biggest thing up here is? This one, right? Isn't 7,001 bigger than any of the other shit? Is that 7,001 though? No. Which one of these is being divided? This is kind of what I'm gonna say it anyway. Which one of these is currently being divided by the biggest number? Does that make sense? What's that being divided by? That's 7 over 100. So which one's being divided by the most? This guy, right? So 7,001 is a big number, but it's being divided by the biggest amount.
7,001, 10,000.
Yeah. So, all right. Who's got the answer? What's definitely the smallest thing up here?
No.
Which one? I love it. That one right there. What? I'm pointing
The
to.
7,001, 10,000.
That's not the smallest.
0.07.
0.07 is the smallest. So what is it that makes it difficult to compare these? What would make it easier to compare them? Say again?
Like fractions?
Yeah, you can make fractions. And once you make fractions, what would you do then? How do you compare fractions easiest if the bottom is
The same.
then you get an LCD? Isn't there a shortcut to do that? What is 0.07 as a fraction?
100.
And if I multiply this by 10, what's that become?
70 over 1,000.
And how do I write that as a decimal? 070. Yes? Officially. Yes?
Yeah.
So I can tack on as many zeros as I want to because it's equivalent to multiplying by 10 over and over on the top and bottom, which is completely legal. Yes?
Yeah.
So 0.07 equals 0.070. So if I just tack on one more zero, if I put enough zeros to make everybody have this many decimal places, then it's going to be easy as shit to compare them. Yes? No? Maybe? Okay. So just like fractions, when do I make it easier to compare fractions? If they all have the same denominator. The beautiful thing about decimals is they are fractions whose denominators are based on 10, so I can make them have the same denominator easy. Easier than any fraction for damn sure. So if one way to do this is to make all of these have 4 decimal places. Now they're all same footing. They're all being divided by the same amount. So whichever one of these, which would be the numerator, is bigger, that'll be bigger. Whichever one's smaller, that'll be smaller. So now it's really easy to see. The smallest dude is this dude for sure, right? I'm just going to bring it back to the normal thing. What's the next smallest?
Would it be the 7?
Did I put it in order?
Yeah.
Oh, I love it. That's funny, Jeff. That's really funny. I just made up some numbers and then I'm like, oh, they're in order already. The ultimate. All right. So I did that one for you. Wait. So this is exactly the same thing as getting LCDs for fractions, right? Making them all have the same place where they end is equivalent to LCD on the fraction. I love it. Yeah, I get it. Appreciate it. Okay. Let me talk about this right now. How could I represent these with any manipulatives we've used before? Manipulatives. How could I do that? What manipulative have we used before that's based on 10?
Flat, long, units.
So real quick, I didn't want to bust this out for everybody, but I'm going to bust it out for myself. Well, that's nice, Jeff. Be quiet. So of course here we have the board, right? Resistance is futile. Okay. No more. Okay. That's Star Trek. Then we have our flats. Oh, wait, wow. Okay. And we have our What are these? Longs, and then we have our
Units.
absolute units, that's right. Oh, turn it on, Jeff. It's amazing how things work better. So, the problem is, so student is used to this representing what? I get it to a point where you can see it. There you go. You guys see it? Okay. Yeah, that represents 100, but now what can we do? We can say this represents 1. Just like the hexagon piece that we cut, we call the one hexagon piece, we call it 1, and then we broke it down into trapezoid. This is 1. So then along, well, how many longs go into this 1? 10. So that's 10 into 1. So 1/10. That would be 1/10. And of course, a little unit dude would be
100.
100. I love it. So if I, for example, had 0.2, so 0.23. Okay, so there's 0.23. And what's nice is they're used to this from before, where this would be 23, but now it's 0.23. And you want to compare that to 0.2. I don't know, Jeff, what you got? Yeah, 0.07. You want to compare 0.23 to 0.07, right? Or let's do, what do I want to do? Yeah, 0.23 to 0.7. There you go, Jeff, you got it eventually. So somebody who's brand new to this might think 0.7 is smaller than 0.23 because 23 is bigger than 7, right? But if I make 0.7, what would it look like?
7 longs.
Yeah, 7 longs. So obviously, visually, 0.7 is bigger than 0.23. Okay. So I just wanted to show that to you. That's reusing manipulatives in different ways. All right. Didn't use any flat, so maybe later we'll bring these back when we're talking about addition, subtraction. Yeah, buddy. Okay. Enough. That was a quick little side note. Maybe that time I'll let you play with them yourselves, but this time they were just for me. Now, here comes some old favorites back. I don't know, I always think about which phrases do I say that scares you the most. So some old favorites. So for example, if I had to add 1.7 plus 1.2 plus 8.3. What's the idea you think that we could apply here?
Compatible numbers? Compatible numbers?
Yeah, compatible numbers. Which numbers here are compatible?
1.7 and 8.3.
Yeah. Right. And the beautiful thing is, if they all have the same decimal place, you can actually think of this as 17 plus 12 plus 83. Get the answer and then put the decimal back in. But what is 1.7 plus 8.3? 10. A nice whole 10. And then 10 plus 1.2? 11.2. I love it. Kick ass. What do you think we could use here? Did I skip something? No, I didn't. That's coming up. 0.5 times 11.9 times 20. A little times in there. It's actually the same idea.
Yeah, so we would.
Aren't these
do
compatible?
10. Yeah,
In a way, because what does 0.5 mean?
half.
Half. So what's half of 20?
10.
10. And multiplying anything by 10 is easy as shit, right?
Yeah.
Because why do you do the decimal place? Skip it. So if I multiply 100, I skip it twice.
Uh-huh.
If I divide by 100, I move it back twice.
Yeah.
It's beautiful. Why does it work so easy? Because 10 is what our number system is based on. So 10 should work really well with our number system. I love it. Bam. What about, oh yeah, 18 times 7.5.
So we would do compensation there?
Compensation, I love it. Right? What does the 7.5 need to become nice?
Two.
A factor of 2.
Yeah.
So if I take a factor of 2 away from 8 and give it to the 7.5, what is twice
15.
15, right? Twice 7 is 14, twice a half is 1, 15. So 9 times 15, and now what can I use for this? Another strategy.
10, make it multiplied by 10.
Yeah, so you can make 9, 10 minus 1, right?
Mm-hmm.
All right, you guys remember all this a little bit? A little tiny bit?
Did we see this in this class?
Say it?
Okay. That was a joke.
Oh.
Like, did we see this in this class?
Wait a minute, is this class about math? I didn't know that shit.
Having a deja vu.
I understand. Is that all right?
Yeah.
So again, just because we're getting into decimals doesn't mean, basically most of our old strategies can be reused again for decimals. This last one is interesting. Let's do this. Let's see if you guys can remember this. How could I do 8.21 minus, what'd you make it, Jeff? Sure. 3.97. Now that problem, we could do it, right? Do you want to? No, because you set it up, you line up the decimal point, borrow bullshit, right?
Yeah.
Who remembers a shortcut or a strategy? Strategery.
Would we do like a similar compensation, make it 4?
Sort of, yeah.
Uh-huh.
If only that guy was 4.
Yeah.
But if I increase what I'm subtracting, I better increase this by the same amount,
Yeah.
right? So this is called like equal additions, if I remember correctly.
Uh-huh.
So if I make him go up by 0.03, make him go up by 0.03, I get 8.24 minus
4.
4. Now that's easy as shit.
Yeah.
Woo. Okay. All right. And we sort of did this already, but just to really make a point of it. If you had to do 0.25 times 4,884 without a calculator, why is that not a problem? What is 0.25? 1/4, right? So the book, of course, calls this fraction equivalence. We basically already done this earlier. To replace the decimal with its equivalent fraction, and I, of course, made this number really nice, so it's just 1, 2, 2, 1, yes.
Very nice.
Very nice. I like it. So, I'm gonna let you guys think about this one. Don't say anything out loud. See if I remember what the hell it was. Yes, that's right. Do something similar to what we did in part A. So what fraction equivalent did you discover? 0.2 is, of course, 2/10, but that becomes 1/5. Of course, course, then the answer would be
1.
Allowed. Freaking, yeah, so, yeah, you know, and we're used to, I don't know, I say we, I don't know how much you guys deal with this in everyday life, but this just makes sense, you know, if I'm gonna approximate, if I had like 0.23 times 5,000, I could just make it 0.25 times 4,000 something. Approximate, right, estimate, make the 0.23 into a decimal, that becomes a fraction real easy, right?
A lot of this is like life skills if you're like a waiter or, you know, things like that. You're like trying to.
Yeah, I mean, it happens every now and again, and a lot of people, you could live your entire life and use no math. That's completely, it's 95% true. Right? Not use math on purpose, right? But if you know math, there's more shit you can do, more stuff you can handle, right? Can somebody tell me anything about this statement right there? Does that look familiar to anybody? Not the specific numbers, but this form.
It's like simplified taking the calculator.
Okay, sure, but there's a specific name for this form. Scientific notation. I love it. Now watch this, it's kind of cool. We're gonna do this the long ass way, and then I'll show you the shortcut way. What is this as a fraction? Let's see if you guys can handle this. What is 4.91 as a fraction?
491 over 1,000.
Say again?
491
Yes.
over 1,000.
491 over not 1,000. No. What place is this in?
100.
Hundreds, right? Now real quick, let me see. Does anyone think it's 4, right? 4 and 91 hundredths. Is that cool? Yes?
Yeah.
But if you do this, 100 times 4 plus this, isn't that just freaking 491?
Yeah.
Right? So what's beautiful is all the freaking digits, that you just put them down, and whatever the last digit is what tells you what place you're in. It doesn't even matter to sit in front of the decimal. It just all gets crammed down there. It's kind of nice. And what does 10 to the 5th look like?
10 times 10.
Sure, but how many zeros will it have? 5. Good. And I could put this over 1 if I want to, right? So what happens here?
So 2 zeros.
Bam, 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 bam. So now you get 491,
3 zeros.
3 zeros. Now, does somebody know a shortcut to go from here to there? Well, yes, you do. What happens every time I multiply by 10? The decimal gets moved 1. So how many times am I going to move the decimal place? So 1, 2, 3, 4, 5, right? So if I had to do 0.3 times 0.07, and I don't know how decimal multiplication works yet, why can we still do this problem? We can do it. Thinking what we did here. What can I do with that problem so that I haven't taught the students how to do decimal multiplication. You guys remember it's a little weird, you gotta count the number of places, blah, 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 right?
Yeah.
But we know the decimals are just freaking fractions, yes? So what is 0.3? 3 over 10. What's 0.07? And is this hard? That's easy as shit, right? Okay, Jeff. So 3 times 7, 21. 1, 2, 3 zeros. I mean, that's just too easy. I mean, multiplying powers of 10 cannot get easier. You can't. Unless it's go to sleep. That's my, your assignment is to take a nap. Oh, good. This is just above taking a nap, right?
Just count the zeros and put it.
Does that match up? Do you guys remember how to do this? How do you do this? Let me put you up here. How do I do this by hand?
They multiply and then just move this.
Yeah, good. 3 times 7, 21. Pretend like there's no decimals, right? And then I got 1, 2, 3. So 1, 2, 3. 0.021. Is that what we got here?
Yeah.
Yeah, 21 thousandths. But do you see how this first, then you can build this on top and you can point back to this. Again, build off of what they're used to. Okay. I just wish, I don't know, to be honest, I haven't looked at every curriculum ever, but I don't see the connection as much as it should be between decimals and fractions, and the fact that decimals aren't just fractions. So everything you learn about fractions, you can apply to decimals if you rewrite them.
Yeah.
But do you want to do that? No, this way you want to learn a shortcut like this, right? Okay. What do you guys think? You guys upset if I let you out now? Like, this is not what I had paid for the whole damn time? Okay.
Take the rest of the brownies.
No, I'm not.
No, I mean,
No,
in the
this is
general,
bad. They will be gone by the time I get home. And then I'm like, well, shit.
they're very healthy. It's all, you know.
Oh, sure. I'm sure that they increase my health if I eat more.
Have you ever watched Soylent
I'll
Green?
take.
Please take 1 or 7 brownies on the way out.
Have you ever watched Soylent Green?
It's people.
Yeah.
Yeah. Oh, is that what's in your brownies? That's
Yeah,
interesting.
pretty
Thing to.
I said they're vegan. They're actually made
They're actually
from
vegan.
vegan.
I should have had like Girl Scout cookies.
Oh yeah, they're real green. Girl Scout.
Yeah.
Did you try some?
Oh, let me grab one.
Yeah, take them.
Oh, exactly, yeah, they're very good.
Yeah, take them home.
Did
There's
you
no
make
one,
them by
there's no one
scratch?
expecting them. Huh?
Or are they by scratch?
Halfway. Like it was like a cocoa mix, and then the egg was like flaxseed meal, and then they're very rustic. Water, oil, and then yeah. Catch you guys next week.